didn't have enough time to do the notes for the whole thing. So I've cut it. We're going to do divide, square roots, and then Wednesday we'll do more dividing because we need to do a little bit extended version of it. We're going to do the algebra 1 geometry side of it.
Hi, ma'am. I have a little COVID gift for you, a little survival kit. I hope that helps you get through the week.
Oh, I hope it does too. Thank you. Oh my goodness gracious. Okay. And then we'll continue it on Wednesday. Today is kind of the Algebra 1 geometry side with a little bit of Algebra 2 in it, and then we'll pick up with it on. I would love to do a test. We had said we would try to do it before Thanksgiving. Now, obviously, that is not possible. If I do a test, I'm going to try to do it the week we come back. You realize you only have 3 weeks of school till exams, this week and then the 2 weeks after Thanksgiving and the exams. If your average is not where it needs to be, because remember, your semester average is, let's see, it's 2 times your first quarter, 2 times second quarter, 1 time exam divided by 5 to get your semester average. So you need to be working on that. That's just on my class, that's all classes. So this is 56 and this is the 16th. So it is coming very, very quickly. I think I put on theirs divide radicals. That's probably what I put on the classwork, but it still works pretty easy. This is a rule. Why anybody ever came up with it, I don't know. I'm not the one that decided it, but you never leave and I'm gonna say radical, because that can be square root, cube root, whatever, in a denominator. Now we say dividing, but we're going to be doing them as, like 12 over 3. We'll be doing them like that, as look like fraction division in a denominator. I think it'll come back to you from, and I'll put an exclamation point there, from what we did in geometry. These are very much, the left page is definitely the geometry side of it. So you are going to want to first to simplify / reduce, which you would probably call canceling, as much as you can. I'll show you something else. I think you will remember it, but you don't want to use it until it's a last resort on this type of problem. What we're doing here is what's called a monomial, and I didn't tell them that till I got to page 57, over a monomial. That means there's no adding or subtracting on the top or bottom. It's just a fraction, like this, number 1. Let's do 6 square root of 2 over 2 square root of 8. Now, I can't leave that square root of 8 on the bottom. Now, what I'm calling simplifying is you could break that 8 down. Factor tree, 2 times 2 times 2, and then do that. If you can avoid factor trees, it'll save you a little bit of time. The reducing or canceling, and we said it in Algebra 1, you can, and in geometry, you can cancel the inside, you can cancel the outside. Or, as we say more in Algebra 2, you can cancel rational, or you can cancel irrational, or both. In this case, I can cancel the rational. I can divide by 2. And then over here, I can do, and now be careful because these are under the square root, under the radical. The 2 goes into 2 1 time, and 2 goes into 8 4 times. So on this one, especially in your notes, put 3 square root of 1, and you have 1 square root of 4 left. Now, if you get good at it, you probably can skip that step, but I want you to see what's left. So your left outside, your left inside. Now, can we clean that up? Do we know the square root of 1? So 3 times 1 on top. Do we know the square root of 4?
2.
So we got 1 times 2, so we get 3 over 2. Now in that case, we didn't end up with a square root on the top or bottom, but you cannot have a radical on the bottom. I tend to not do the simplifying because it just takes more time. You know, if I've got to break down the square root of 50, or if I can cancel with it, it makes it a little bit easier. That's kind of like this one. I've got the square root of 28 over the square root of 4. Now see, if you look at it as simplifying, you could go ahead and break the 28. It's going to become 2 square root of 7, and you can write the square root of 4 as 2. But I'm going to treat it as the inside-outside. Now, there's understood ones out front, just like ones in front of x's. But I can cancel my 4 and my 28. 4 goes into 28 7 times. But now recognize that that square root of 7, it's still under the square root, and that square root of 1. The square root of 1 I know is 1. And I'm putting all the steps in. That just makes it a little bit easier for you. We have a square root on top. We don't have one on the bottom. And that's what you want to do. If you can, you want to do all of this first before you have to take that second resort. Let's do one more. Let's do 3 square root of 20, 3 square root of 2. 6 square root of 32. Now, I can't break the square root of 2 down on top. It's irrational, and that's it. But I can break the square root of 32 down if you want to. But I like the idea of reducing the rational part on the outside and the irrational part on the inside. Because 2 goes in 32 16, and that makes my life a lot easier. I get 1 square root of 1 on top, and I get 2 square root of 16 on the bottom. So 1 times the square root of 1 is just 1. But now what's the bottom going to be? So you got 2 times 4 on the bottom, which is 1 over, and I'll even put 1 times 1 on top if you need it, over 8. But then you get to problems like this. Let's do 8 over the square root of 5. And I'm going to start a star here because this is where the split happens. You can't cancel, even if that was a square root of 6 or a square root of 8, I could not cancel these because that's rational. There's a 1 on the outside. There's not a radical, not an irrational part here. I can't do anything. I've got to get rid of that square root of 5. So what we find, if you remember from elementary school, you know, the teacher would take a pizza and they would cut it in half and give you half of it. They would cut it in 6. Do a very good job of that, and give you 3 pieces, or 8 and give you 4 pieces, and you were getting the same. You might be getting more pieces, but you were getting the same amount of pizza. 1/2, 3/6, 4/8, 5/10. It's all 1/2. Well, how that happens is because when you multiply a fraction, I'll do the 3/6 times 1, you get that fraction, and that's true for any number. 8 times 1 is 8. 12 times 1. But what if I make that 1 something like 2 over 2? If I take 1/2 and multiply it, say, by 5 over 5, and I get 5/10. Well, I know those are equal because I've seen teachers do this. They'll put a 1 over that 5 over 5, and so 1/2 and 3 5/10 have to be equal because you're multiplying by 1. Well, that's what we're going to do. We're going to do what's called rationalize the denominator. You may remember this from last year. Rationalize just means you're going to make it a rational number. You're going to get rid of that irrational number right there. And we're going to multiply by the radical. I'm going to do it generically radical because this works for any of them. And I'm going to put in the denominator, because we're only trying to get rid of that square root of 5. Doesn't matter if you have a square root on top. In the denominator, in the form, we could put that in with commas too, in the form of 1. So you find what you need to get rid of, and you multiply it as square root of 5 over square root of 5, which is 1. Now, let's multiply fractions. On top, you have 8. That's rational. This is irrational. You've got a 1 in front of those. So you've got 8 square root of 5. And on this one, you have the square root of 25. See? 1 on the outside and 5 times 5 on the inside. 8 square root of 5, I can't do anything to, But what about the 1 times the square root of 25? What's the square root of 25? It's equal to 5, so you got 1 times 5, which is 5. Now that's your answer. We cannot cancel these because one is, as we said in geometry, one's inside, one's outside. One is irrational, one is rational. We rationalized the denominator. We took this irrational number and made it rational.